Would you like to choose? I'm looking at problems 29 through 44. So let's choose another. A rational function is very important. Something like this, or something with trig, very important. To determine critical numbers. Sorry, which one? 44. This one, x squared, x to negative 2 natural log. Yes? Very good. So we are looking at f of x. So this is 44 on page 281. And this is x to negative 2 times natural log x. Perfect. So here we're asked to determine the critical numbers and see if they change into local max, local min. That part I edit myself. So it doesn't say. We're only asked to find critical numbers, but I don't want to wait. These are connected. They're too close together. Very good. So first of all, can anyone give us the domain of this function? You can say, but wait a minute, you didn't ask on the previous one. I didn't, because there was nothing I could ask. This is a polynomial function. There was no problem there. That's why I didn't say anything. But obviously the domain is our first thought no matter what. So can anyone give us a domain of this function? Careful, it's natural log. Picture the natural log function in your head with your mind's eyes.
X greater than 0.
Greater than 0, very good. 0 to infinity. Let's graph natural log one more time. Natural log x. So the graph, this function has a vertical asymptote at 0. You cannot even plug in 0 in natural log. It has to be strictly greater than 0. Applied to strictly greater than 0 numbers. Okay, perfect. Good. Why do I need this? Because of this. Of course, I need my table. So I'll have f prime. I'll have f of x. I'll put 0 to infinity. And immediately under 0, I would write, sorry, if the function doesn't exist at 0, its derivative has no, it can't exist. Very good. So then, I'll come back to it. So now we go back and we differentiate the function, right? So let's differentiate. So f prime of x, remember, this is a perfect review, right? It's a perfect review for our test. So we have a product of two functions. We have to use the product rule and differentiate this function, find the derivative. Ready? So the first function prime is negative 2x to negative 3 times natural log x plus, remember when we apply the product rule, we get a sum of two products. So the first function prime was negative 2x to negative 3 times natural log x and plus x to negative 2 times, that's it, 1 over x. Great job. Now be very careful with this because this is basically 2 natural log x over 3 plus, you know what I meant, plus 1 over x to the third. So I brought x to negative 3 to the denominator. And of course I brought x to negative 2 to the denominator. And I'm happy because I see that they have the same denominator. So then this is negative 2 natural log x plus 1 over x cubed. If you remember, I insisted some time ago, no negative leading coefficients, although you can say, but this is not a polynomial, what are you talking about, leading coefficient? True. I just don't want to see anything that starts with a negative in there. You can reverse them if you want on this problem, but that's fine. So now we want to find the critical numbers. We determine the derivative. So remember, critical numbers come from f prime of x being undefined or from f prime of x equals 0. So now the question is, does this function have a critical number coming from f prime being undefined? And you will say, yes, x equals 0. But it's in fact no, because the function itself doesn't exist at 0. So even if this function is undefined at 0, it's not a critical number because the function itself is undefined at 0. So nothing coming from this. Good. So the only possibility, in case this function has critical numbers, have to come from here. But this is a fraction. When is a fraction, which that's the derivative? When is a fraction 0? Only when the numerator is 0. 2 natural log x minus 1 equals 0. So if this equation has solutions, the original function has a critical number. If this equation has no solutions, the original function doesn't have a critical number. So I have to move 1 and divide by 2. Natural log x equals 1/2. And now I have to remember what this represents. So a log equation can be changed into an exponential, and an exponential can be changed into a log. How do I change this into an exponential? What is the base here? I don't see a base. E. Very good. E raised to 1/2 equals x. Or x equals e to 1/2, or x equals the square root of e. Okay. Okay, so I determined the critical number. I don't know if this changes into a max-min, but I will in a minute. I will find out in a minute. Okay, so here is the derivative. The square root of 2 point blah 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 is more than 1. So 1 is in here. So let's plug in 1. And please tell me the sign of the expression. 1 in the denominator. When I plug in 1 in natural log, what do I get? Log of 1 is 0. Very good. So this is 1, this is 0. I have a minus and I have minus 1. What is the sign of the expression between these two? Very good. Now I'm going to choose 10. 2 natural log 10 minus 1. I don't need to put it in here. It's just a positive number with minus in front. Let's say I don't know. That's fine. If I don't know, I have a calculator. And I have 2 natural log 10 and then minus 1. And the answer has to have minus in front because of this. So it is negative indeed. Now I have to determine this number. So in the original function, which was x to negative 2, I'll plug it in. So I have x power negative 2 and multiply by natural log of x and go to second and table, and I probably gave it to somebody who did that. Okay, so now I want to plug in the square root of e. And I get 0.18. I'm happy with that, or 0.184. And now I know exactly what this point is. The square root of e, comma, 0.184. Now you could say something I said to you a few minutes ago, but you don't have an exact number. Yes, I should have never, and we should, to give you the exact max, I should have never approximated. So I should have just plugged in the square root of e. And if I do that, it's going to be natural log e, which is 1. This number is 1 divided by e. That is the correct answer. Because this is an approximation, and you can say you said you rounded up. That's not the exact, and that's true. So the actual max is the square root of e, comma, 1 over e, or e to negative 1. It was e to negative, it was 2, right? Sorry, squared. Because the function, the original function was x to negative 2 natural log the square root of e. Okay, I messed up. No, it wasn't the square root of e. Yeah, yes, this is the square root of e. So the square root of e, yeah, I messed up. I have to give it the correct answer. Sorry. I'm gonna have to do that again. That's the approximation, but I don't want to approximate. I just want to show you. So one more time, this is this. That's the original function. I have to plug in the square root of e. So this will be, yes, so the square root of, so natural log the square root of e over the square root of e squared. Okay. So this gets changed into the square root of e to 1/2, and I bring 1/2 in front. So the numerator is 1/2, and the denominator is e. So then it's 1 over 2e, the correct answer. 1 over 2e. And that's the 0.184. That is the correct. So yes, I have to approximate it because I don't really know what that means. So I have to approximate it, especially when I graph it. Because if you ask me, graph the square root of e comma 1 over 2e, I'll say, what? So I would have to approximate. I will not be able to plot that. Okay, now I still want to determine this and this. What do I mean by that? Well, this time I have to find a limit. The limit as x approaches 0 from the right of the function. Let's do that. So limit of natural log x divided by x squared as x approaches 0 from the right. Also, I need to find the limit as x approaches infinity from natural log x over x squared. That's another reason why we studied limits. Because now we want to be able to graph these functions or see their trend or find their end behavior or find the behavior near vertical asymptotes, and we can do it without limits. So what do you think about this? Well, when I plug in 0, the top is infinity and the denominator is 0, so it's a mess. But I can rearrange it easily. And I know that this approaches, when x approaches 0 from the right, what does it approach? Careful, careful, careful. When x approaches 0 from the right, natural log approaches, very good. So this approaches negative infinity. So now let's look at this one. Where does this go? Let's graph it. So remember the graph of 1 over x. That's why I tortured you with them from the very beginning. This is the graph of 1 over x. But that's not what I have. I have 1 over x squared, which will be this. This is 1 over x squared. So as x approaches 0 from the right, 1 over x squared approaches. Very good. And now, from something that was impossible, look what I have. Infinity times negative infinity. What is the answer? Negative infinity. So this is negative infinity. Now I want this one. So natural log, when x approaches infinity, where does it go? Remember the graph. When x approaches infinity, natural log goes to, very good. When x approaches infinity, x squared goes to, very good. But I don't have problems with this one because I studied a very nice theorem that says whenever I determine the limit of a ratio, that's another review for next week. whenever I determine the limit of a ratio and I have either 0 over 0 or infinity over infinity, what will I do? L'Hopital's rule. Inside the limit only. The derivative of the top. The derivative of the denominator. Excellent. So then this becomes limit as x approaches infinity of 1 over 2x squared. And now you know the answer. You cannot apply L'Hopital's rule anymore because it's not 0 over 0 or infinity over infinity. But I just have the answer, and it's done. What is it? Thank you very much. 1 over infinity is indeed 0. Finally, okay, so now I'm ready to analyze. From negative infinity to 0.18, what does this function do? Is that supported by the sign of the first derivative? By the first derivative test. Okay, from positive 1.8, although tiny, to 0, what does this function do? Very good. Is that supported by the sign of the derivative? So then, therefore, the square root of e, comma, 1 over 2e, what is it? What does it represent? Because of the particular sequence of signs of the derivative. What does that represent? A local or relative what? Very good, awesome. I don't want you to get confused with my scribbling here. Yes, it is indeed a local max. It could be the absolute, and actually it is, because this function starts at negative infinity, it reaches a point, it's increasing till that point and then decreasing to 0, so the other way around for you. So from negative infinity increasing and then approaching 0. So obviously it will also be a absolute max, not just a local max. Any questions? Okay. One more thing, I stopped numbering, and that can turn into an easy tragedy very soon. So this is 8 and this is 9. Okay. So now let's study a function on a closed interval. A function on a closed interval. Okay. Many functions from 47 through 62. Here's the requirement. Find the absolute max, absolute min values of the function on the given interval. A function on a closed interval. They want us just to determine the absolute max, absolute min. I will throw in local max, local min as well. So let's choose. I would like to look at a radical. I would like to look at a rational function. Of course, whatever. Which one?
57.
57, you said? The trig? Okay. It's not going to be an easy one because we'll have to solve a trig equation. So 57. So this is f of t equals 2 cosine t plus sine 2t 0 to pi over 2. Ah, the interval is nice though. Perfect. This time, there is no need to find the domain. This is it. That's exactly what they're telling us. We have to study everything only between 0 and pi over 2, and f prime, of course, and f of x. So everything that happens in the first quadrant, from 0 to pi over 2. So in order to find relative max, relative min, or absolute max, absolute min, it doesn't matter. What do I have to determine first? The derivative, yes. Then I'm asking you, since we are dealing with sine and cosine, do you think that the first derivative will be ever undefined? Correct. It will never be undefined. Very good. So f prime of t is 2 cosine t prime. This is a review for next week, right? So 2 cosine prime is negative 2 sine t, and then plus cosine 2t times the inner function prime. Very good. This will be negative 2, right? Sine t minus cosine 2t. So obviously f prime of t is never undefined. So that's clear. But now I have to solve this equation, which is a trig equation. Ready? So when this is 0, obviously sine t minus cosine 2t must be 0. Okay, so I need to change this in terms of sine. How do I change cosine twice t in terms of sine? There are 3 definitions or 3 identities for cosine twice t. Here's one. Cosine squared t minus sine squared t. Here's the second one. 1 minus twice sine squared t. And here's the third one. 2 cosine squared t minus 1. I only need one. It's in the front cover. It should be in the front cover, the trig identities, I think. So I only need one. I don't need the one with cosine and sine, and I don't need the one with cosine. Obviously, I need only the one with sine. So I am going to replace this by this. So the new equation becomes sine t minus 1 because I have to distribute negative 1, but plus 2 sine squared t equals 0. Now I have to notice that this is not in the correct order. How would you present this? Very good, of course. 2 sine squared t plus sine t minus 1 equals 0. Now we have to find a way of factoring this equation. I'm sorry, this expression on the left-hand side in terms of sine. If you want to use the change of variable, so that's easier, you can just write 2x squared plus x minus 1 equals 0. And then come back and replace x by sine. So we have 2x minus 1 and x plus 1. 2x squared plus 2x minus 1 and minus 1. So this is 2 sine t minus 1 sine t plus 1. You requested it. So then sine t equals 1/2, and psi t, sine t equals -1. Luckily, that's not possible in the first quadrant. There is no angle whose sine is -1 in the first quadrant. So this one does not belong in the table. It's correct, but it doesn't belong in the table. So now what angle has sine 1/2? 30 degrees or pi over 6. Great job. Very good. Now I have to study the sine of this. Let's plug in 0. Sine 0 is 0. Cosine 0 is times -1. -1 times -2. Very good. Let's plug in pi over 2. Sine pi over 2. 1. Cosine 2 times pi over 2 is cosine pi. How much is cosine pi? -1 times -1. How much is 1 plus 1? 2 times -2. Very good. I need these values. So we plug in the function in y equals, and the function was 2 cosine t. Make sure that the mode is back to the irradiance, please. So in y equals 2 cosine t minus sine twice, no, it's not minus, it's plus. Sine 2t. Second and table, I want 0. I want pi over 6. And I want pi over 2. Yes, you will say, well, you can't really put that 2.5981 and because you're not going to give us the exact answer. I will have to agree with you. In order to be exact and correct, I should keep it without approximation. But I can't. If I want a graph, I have to have an approximation. So at 0 is 2. At pi over 6 is 2.6. And at pi over 2 is 0. Now we have to make sure that these two rows work well together. If they don't, we have an error somewhere. Ready? Between 2 and 2.6, does the function increase or decrease? Is that supported by the sign of the first derivative we discovered? Between 2.6 and 0, the function is? Is that supported by the correct sign of the derivative? Okay, so here's the situation. I'm not graphing the function. So this is the height of 2. Then it goes to the height of 2.6. And then it comes down to the height of 0. What does this point represent? This point is nothing. What does this point represent? Pi over 6 comma 2.6. Yes, global max, but it's also relative max. What about this point, which is pi over 2 comma 0? What does this represent? It's the smallest possible for the entire function. What is it? Global min. So the point 0 comma 2 doesn't mean anything in the sense that it's not a global max, it's not a local max, it's not a global min, it's not a local min. This one is the absolute maximum. The function does not go higher on this interval, of course. So that is a global max because of the sign change of the derivative and because it's a critical number at pi over 6. And it's also a relative relative max, because I can show the open interval where all these values left and right are smaller than 2.6. Point pi over 2 comma 0 is a global min, because for this function on the interval 0 pi over 2, there is no other value that is smaller than it, because it goes from 2, goes to 2.6, and then to 0, and it's done. Doesn't turn, doesn't do anything else. So this is how we study a function on a closed interval to determine local. The book really says just absolute max min, but we can identify which one is a local. Of course, even this or this cannot be no local, because it's at the endpoint of the interval, and this one 0 comma 2 is really nothing. Questions? Questions? I still would like to look at a rational function, if you don't mind. Is that a yes? Okay. Or we can go ahead and look at a word problem. It's up to you. So let's just read this word problem quickly, and then we'll decide whether to look at rational functions first, and then look at this word problem. So let's read it together. Between 0 and 30 degrees Celsius, the volume V in cubic centimeters of 1 kilogram of water at temperature T is given approximately by the formula. So we have a function which is V of T, V of uppercase T. It's a cubic function. Find the temperature at which water has its maximum density. The rate of change of volume with respect to mass. The other option that I had in mind was to look at finding the absolute max, absolute min, and of course we can also identify local max for a rational function. Which one would you like to start with?
Four.
54. Very good. So let's start with 54. Thank you, Matt, because we kind of got stuck. I'm not sure. Yeah, you took us out of that zone. Good. So we look at 54, and that is f of x equals x divided by x squared minus x plus 1. And again, there is no discussion of domain. This is never 0, actually. The domain is given to us carved in stone. It's between 0 and 3, and we can't change that. Well, we can discuss max min without looking at the derivative and finding critical numbers. Those are the first steps. If the function has no critical numbers, there is no point in discussing max min at all. So in order to find critical numbers, we have to find the derivative. That's our first step. So f prime, we have no choice. This is one particular type of problem. Remember, we looked at something like this, even more complicated than this. And we are definitely going to be interested in completely simplifying the derivative, because if we don't completely simplify the derivative, we will not be able to find the critical numbers. So that's one of the problems that we worked on last time. Okay? Good. So the top function prime is 1. So this is x squared minus x plus 1 minus the top multiplied by
Uh,
2x minus 1. Very good. Awesome. We have to distribute. We have no choice. So this is x squared minus x plus 1 minus 2x squared and plus x. divided by x squared minus x plus 1. Luckily for us, the x and the negative x go away. Also, luckily for us, the x squared minus 2x squared will be negative x squared plus 1 over x squared minus x plus 1.
Can't distribute the x squared
Say it again.
We can't make it so the x to the fourth power minus.
You mean this one?
Yeah.
Ever. It's not going to give me anything. So negative x squared minus 1 over x squared minus x plus 1 squared. Negative x plus 1 x minus 1 over x squared minus x plus 1. Note, do not touch. You mean what I mean? Expand. That's what I meant. Do not touch the factors in the denominator. You're not going to do anything with them, and you're going to waste your time. Okay, so this is our derivative. Is this ever undefined? You can say maybe, but so will be the function. When this is 0, which will never happen, x squared minus x plus 1 is never 0. If this is 0, then so is that, so the function will not be defined if there are critical numbers coming from f prime being undefined. The function will not be defined. So the only possible critical numbers can come from what? Yes, from f prime being 0, correct. Not from the top, but you know what I mean, yes. So what are the critical numbers then? X equals -1 or x equals 1. Very good. Again, -1 has no place here. It does not belong here. I'll say no for that one. It's correct. Everything is correct, but it doesn't belong here. So I only have 1. Good. So now I'm going to copy the derivative, or maybe not, but I like to talk about it anyway. So negative x plus 1, x minus 1, over x squared minus x plus 1 squared. I'm going to plug in 0 to study the sign on this side. 0, 0. 1 times -1 is -1, minus 1 is positive, and this is always positive. I shouldn't even talk about it. So this is positive. I'm going to plug in 3. 3 plus 1 is positive, positive. 3 minus 1 is 2. 2 times -1, negative. I absolutely need these values. When I plug in 0, I see the function is 0. When I plug in 1, these two go away, so I get 1. When I plug in 3, I have 3 over 9 plus 1, which is 10 minus 3, 7. So 3/7. Now the moment of truth. If these two rows don't work well together, I have to go back to the drawing board. I have a mistake somewhere, or more than one maybe. So from 0 to 1, what does this function do? Is that supported by the correct sign of the derivative? From 1 to 3/7, what does this function do? Good. Is that supported by the sign of the derivative? Perfect. So again, I'm not graphing the function. I'm just giving you the idea. So I'm graphing basically the y coordinates. 0, then it goes up to 1, and it goes down to 3/7. Something like this. This is not the graph of the function. I'm just looking at the y values. Can anyone tell us what is 0, 0? Global min. Very good. Can anyone tell us what is 1, 1? Global max. Of course, also relative max. Can anyone tell us what is 3, 3/7? Nothing. Indeed, nothing. Any questions? Any questions? So you understand that finding a critical number, it's not sufficient to conclude max-min. We need to study the sign of the derivative. The sign of the derivative together with a critical number will tell us whether the function has a max or a min or none of the above. So just finding critical numbers, you can say, hey, I found a critical number, is x equals 2. It's a max or it's a min. You can't. You have to show the sequence of signs. And if there is no sign change, there is no critical number. There is no max min, even if there is a critical number there. Okay, so we still have a few minutes. Let's look at the word problem now. I don't want to start a new section. I let you decide. You want the word problem or you want another problem to find max min, critical numbers, and absolute max, absolute min, or the word problem. Word problem? Okay, perfect. So let's read it. We just looked at it a minute ago. Let's get it again. So we have a function where it has to find where it has its maximum. So I'm going to copy the function. And then I'm going to find the derivative. And then I'm going to say, first of all, this is a cubic function. So no critical numbers will come from f prime being undefined. But I'm hoping that I will find critical numbers coming from f prime of x, or in this case, v of t equals 0. And then we'll have to study the signs to make sure that it changes sign. So this is problem 69 on page 281. V of t equals, and I'm going to put it in correct order. I think I see 4 zeros. And 679 t cubed, and then plus 0.008543 t squared, and then minus 0.06426 t, and then plus 99987. It's not that I care for that, it will go away anyway. Good. I'll get my table going. The temperature, they say, is clearly between 0 and 30, and I have to make sure that I talk about 0 to 30. So then v prime of t, and this is v of t. So this is a typical example again of a function on a closed interval. So we are specifically told between 0 and 30. Okay, so let's find v prime, which, by the way, it's not friendly at all. So v prime of t is, okay. Okay. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm trying to put a function, an ugly function, on a tiny little piece of paper or area. And there is no need for that. I just got a new type of paper. I have to use it. Okay. So v prime of t. So it's minus, and that's t squared. Okay, so how much is this? 0.000, 3 zeros, yes. I got this. Please correct me if I'm wrong anytime. Plus 0.0. So let's see. So this is 6 and 8 and 0 and 0 and 16, 17. Yes, and t minus 0.06426. This is what I got. And if you got something else, you may be right, I may be wrong. So let me know. Did we get the same thing? Okay, so now I have v prime of t equals 0. So negative 0.002037 t squared plus 0.0170086 t and minus 0.06426 equals 0. I will multiply both sides by negative 1. 0.0002037 t squared minus 0.0170086 t plus 0.06426. So 6426. Okay. Now the quadratic formula, of course. This 0.0170086 plus or minus the square root of 2 times this. So 37 times 2, is it 74? And 0 and 4. 0, 0, 0, 0, 0. And then this squared, 0.170086 squared minus 4 times this times this. 0. 2037 and times 0.06426. Okay, ready? Okay, so don't forget parentheses around the numerator, parentheses, denominator doesn't need it because it's just one number. Left parenthesis, 0.0170086 plus the square root, parentheses, 0.0170086 squared minus 4 times 0.0002037 times 0.06426. Close the parenthesis, go outside, close the parenthesis, and divide by 0.004074. And the other one with a negative. Okay, so I got two solutions for a temperature of, I'm gonna say 79.53 degrees, or of 3.967 degrees. Okay, obviously this is fine, but it doesn't fit, so I'm gonna say 4 degrees, where it's 0. So now we have to study the sign, which is not bad because I can plug in 0. So where's the verb? Yeah, here it is. So 0, 0, so it's negative. And outside, because the solutions are, so between 3 and this is positive, yes. Now I have to plug in 0, 4, and 30 in the original function, which is this ugly thing. Well, when I plug in 0, I have no problem, is 999.87. When I plug in 4 and 30, I have no clue what's happening there. So in y equals Negative 0.1234679 x cubed plus 0.008585043 t squared minus 0.06426 t, and then plus the 999.87. And I know I want only two values. I want 4, which is not exactly 4, really. And I want 30. Okay. So at 4 is 999.74, and at 30 is 1003.8. Okay, now we can draw a conclusion. From 999.87 to 999.74, what does this function do? Yeah. From 999.74 to 1003.8, the function is. So the question was, find the temperature at which water has its maximum density. At 30 degrees. So this is the absolute max, of course, on the given interval. I don't know what the function does outside of that, but on the